Hey guys, welcome back to electronicsinnovation.com. Welcome to series of videos on sensors. From now onwards, I will take a sensor and try to interface with different microcontrollers like Arduino Uno, ESP32, ESP8266 and print the sensor data on different displays like 16x2 LCD display and I2C OLED display. Also, we will post data to simple web server and display the same data on mobile and computer screens. At last, we will perform the durability and compatibility test and will give you the complete review of the testing. In this video, we are going to see all about this K-type thermocouple sensor with MAX6675 breakout board. First of all, we will interface the sensor with Arduino Uno and display the sensor data on 16x2 LCD display. In the next video, we will display the same data on OLED display. Thereafter, we will perform durability or capability testing for this sensor to determine the maximum temperature this can measure. Then we will interface the sensor with ESP32, ESP8266 modules and display the sensor data on simple web server. So without wasting time, let's get started.
PCBWay.com is one-stop solution for PCB prototyping, manufacturing and PCB assembly. Along with PCB prototype, PCBWay is also making assembly stencil within one day production time. If you are using assembly components on your PCB, you should have this assembly stencil. You can get it easily from PCBWay.com. Just choose stencil type, size, stencil side and quantity. Then click on quote now. Check other advanced parameters here, then calculate. You can get it at $15, which is the best price in the current industry. Select the shipment method and complete the order. Required components are breadboard, Arduino Uno board, 16x2 LCD screen, OLED display, sensor breakout board with MAX6675 IC, K-type thermocouple sensor with the probe, screwdriver to connect the sensor probe and breakout board, finally a bunch of connecting wires to interface all these modules with each other. Before jumping into the hardware connections and programming, let's understand the facts and capabilities of this sensor. Here is the thermocouple sensor with probe. The thermocouple sensor will be mounted here. The sensor connection is extended with a probe which is insulated from the heat. At the end of the cable, there will be a lug to connect with MAX6675 sensor breakout board. Here is the breakout board with MAX6675 IC, screw terminal connector to interface with K-type thermocouple sensor, and a 5-pin right-angled budge tip to connect with the microcontrollers like Arduino, ESP32, ESP8266 and STM32. This MAX6675 IC will read analog voltages from K-type thermocouple sensor and convert to the digital data and send this data to the master microcontroller via SPI protocol. Let's connect these two. This red colored lug should connect to the positive and blue one should connect to the negative. Here is the circuit diagram to interface MAX6675 and LCD screen with Arduino Uno board. After all connections, the circuit will be something like this. Arduino Uno will read the data from the sensor and print the same data on LCD screen. Coming to the programming part, here is the code to interface MAX6675 with Arduino and print sensor data on LCD screen. This code will be available on the project page which is mentioned in the description below. These are the libraries we are using. These libraries can be installed directly from the Arduino library manager itself. Go to the library manager, type liquid crystal, install the first one. Repeat the same process for MAX6675 also. I have also given the GitHub link of the library. You can download it using this link and install it. Creating an LCD object and passing pin numbers as parameters. Declaration of sensor pins, data output as 8, chip select as 9, clock as 10. Creating a MAX6675 object and passing pin numbers as parameters. Coming to the wired setup, initializing serial monitor at 9600 baud rate, begin LCD with an object and clearing the LCD screen. Coming to the wired loop, reading sensor data and storing into the variables. The temperature in Celsius format is being stored in the variable T and Fahrenheit is being stored in the TF. Then printing the same data on serial monitor using these lines. Then after printing the temperature in Celsius format on LCD screen. This line will print the degree symbol on the LCD screen. Printing temperature in Fahrenheit format on the LCD screen. So let's upload this code to the Arduino. Connect the Arduino Uno with laptop and check the uploading configurations board Arduino Uno and select the right port. If everything is okay, upload the code. After successful uploading, open serial monitor. If the sensor is working, you can see the temperature data on the serial monitor. You can also see the temperature data in both Celsius and Fahrenheit format on the LCD screen. The temperature will be updated for every 500 milliseconds. Now it's printing current room temperature. Let's increase the temperature at the thermocouple and see what happens. So as you can see here, the temperature on the LCD screen is keep on increasing as I have started heating the sensor now. I am impressed with the performance of the sensor because the sensor is very good at giving fast readings. That's it for this tutorial. This is how we can measure the current temperature and display on the serial monitor as well as LCD screen. You may get irritated with these messy connections. You can use the I2C LCD screen to eliminate these connections, or you can use this I2C OLED display to print the temperature data with just 4 wires. This display is very easy to interface with Arduino Uno and display the temperature data. We will see this in the next video. See you soon on the next video. Bye bye.